In this video, I'm going to show you how to do AQA A-Level Maths Paper 1 from June 2018, question 6. My name is Sunil Tanna. I'm a tutor and author. My details are on the card. I'm available for one-to-one tuition, both online and in person. I live in Buckinghamshire in England. 6a. Find the first three terms in ascending powers of x of the binomial expansion of 1 over the square root of 4 plus x. Okay, first thing to notice is that the square root of something is to the power half. If 1 over that is to the power minus a half. So we could rewrite this as 4 plus x to the power minus a half. Now, if we want to use binomial expansion, both terms within the binomial need to be the first term needs to be 1, and the x term needs, or the second term needs to be between minus 1 and plus 1. It needs to have an absolute value of less than 1. So we need to deal with this 4. So what we do is going to take it out of the bracket. So if you think about this, this could be written as 4 times 1 plus x over 4 all to the power minus a half. And using our laws of indices, we could rewrite that as 4 to the minus a half times 1 plus x over 4 to the minus a half. And 4 to the minus a half is 1 over the square root of 4, so 1 over 2. So we could rewrite this as equal to a half times 1 plus x over 4 to the minus a half. And now we can use our binomial expansion. So now we'll be approximately equal because we're only going to include the first few terms. So by omitting the later terms in the binomial expansion, we won't have the exact value of this expansion, but we will have a value close to the final value. So it's going to be approximately equal to a half. And now we use the formula 1 plus n, which is minus a half, times x, which will be x over 4, plus the third term would be n, which is minus a half, times n minus 1, which is minus 3 over 2. The x term would be squared, so x over 4 squared, all over 2. And that would be the first three terms. Obviously, there would be other terms after this, dot, dot, dot. And that would be our expansion. Now all we need to do is simplify this. So we just need to expand it out. So we've got a half times 1, which is a half, plus the second one is going to be minus a half times x over 4. So it's actually going to be a minus x over 8, but it's also times a half again at the front, so x over 16. The third term, we have to be careful here because of this square. The top of the fraction is going to have an x square. It's also going to have a 3 on the top, and on the bottom we've got 2 times 2, which is 4. 4 times 4, because it's 4 squared, is 16. So 4 times 16 is 64, times another 2 is 128, and times that half at the beginning is 256. What about the sign? Well, there's a minus times a minus here. Everything else is positive. So there's two minuses. So minus times a minus makes a plus, so this is a plus. And then there would be remaining terms, but we're approximately equal, so we could just omit those. That's how you do part A. Right, in part B, we have a very similar binomial expansion, but you'll see instead of the plus x, we have a minus x cubed. So what we can do is just substitute a minus x cubed into the original binomial expansion. So this binomial expansion will be, again, approximately equal because we're only including the first two terms. A half minus, instead of x over 16, it will be minus x cubed over 16. And the next one will be 3, and instead of x squared, it will be minus x cubed all squared over 256, and then additional terms which we're going to omit. And all we need to do again is simplify that. So approximately equal to a half. We've got a minus times a minus makes a positive, so positive x cubed over 16. We've got minus x cubed squared, which is x to the power 6 positive, times 3, which is plus 3x to the 6 over 256. And again, we're missing the later terms. So that's part A and B of the question. We now need to move to the next part of the question, part C. So in part C, it asks us, using the answer to part B, find the approximation for this integral, giving your answer to seven decimal places. So we can substitute in the expansion that we used in part B for the term that's inside the integral. So the integral becomes the integral from 0 to 1, and then we're using our expansion. We've got a half plus x cubed over 16 plus 3x6 over 256, obviously additional terms which we're omitting, and then dx between 0 and 1, and this will be approximately equal because again we're missing the later terms of the series, of the expansion. Okay, and now what we need to do is put in the limits of the integral, do the integral and put in the limits. So first of all, integrating a half gives x over 2. Integrating x cubed over 16 will increase the power by 1, so it'll be x to the 4, and divide by 4 would be x to the 4 over 64. And here again, 3x6 over 256 will be 3x7. We need to divide by 7. 7 times 256, we put that in the calculator, and that comes to 1,792. Obviously, we're omitting any later terms in the series or the expansion, and we need to put in 1 and 0. Okay, and if we put in now 1 into the first one, we will get a half plus 1 to the power 4 is 1 over 64. 1 to the power 7 is still 1 times 3 is 3 over 1,792. Minus putting in 0 as a limit, we have 0, 0 and 0. And then if we put that into a calculator, we can get our 7 decimal place answer, which is 0.517291. And that's part C of the question completed. Okay, part D says, Edward, a student, decides to use this method to find a more accurate value for the integral by increasing the number of terms in the binomial expansion used. Explain clearly whether Edward's approximation would be an overestimate or an underestimate, or it is impossible to tell. Well, if we look at our binomial expansion for this integral, we'll see that every term is positive. So so the first thing is all terms are positive. So if we added more terms, the value would be larger. Adding more terms would give larger value, which is closer to the exact value. The more terms we add, the more accurate the expansion is. So because we're omitting the terms, therefore we are underestimating. Okay, and that's part D1 of the question complete. Final part of the question, D2. Edward goes on to use the expansion from part B to find an approximation for this integral between 0 and minus 2 are the limits, minus 2 and 0. Explain why Edward's approximation is invalid. Now, if you go back, you will see that the original expansion was for, the binomial expansion was for, so the original, which was in part A of the question, in A, was the expansion of 1 plus x over 4 to the minus a half, which is valid if modulus of x over 4 is less than 1. So in part B, we changed that to being minus x cubed. So the part B of the question, part B expansion, valid if minus x cubed, modulus of minus x cubed over 4 is less than 1. Okay? And that was the, you continued through into parts C and D1 of the question. So if you think about this, first of all, the minus x doesn't make a difference. So really it's valid, which tells us valid if x cubed over 4 is less than 1. If we look at that, times both sides by 4, this would be valid if modulus of x cubed is less than 4. In other words, it's only valid if modulus of x is less than the cube root of 4. But for this integral, modulus of x, or x could be minus 2. So the modulus of x could be minus 2. So, but in this, minus 2 is greater than, modulus of minus 2 is greater than the cube root of 4. So not valid. So that's the reason for part D2.